Hello friends, today we will see topic number 10, surface and line models. Overview. This chapter discusses structural and thermal simulations response of problems that can be analyzed with surface or line models. This includes plane stress, plate problems, line body problems. Introduction. Surface models are often easier to develop and easier to solve than solid model and can be employed in many practical situations if they can accurately represent the behavior of the project. Under consideration, we are interested in a two-dimensional surface models for plane strain, or axis symmetric analysis, and the three-dimensional surface models for plate analysis. Plate or cell structural components are surfaces that resist loads applied normal and parallel to their surfaces and provide resistance to bending and in-plane deformations similar to beam components. The plate surface of the deck of a ship is a typically example. Seat with a circular hole plane stress. In this tutorial, we will use the ANSYS simulations to compute the maximum stress in the thin steel sheet with the central hole considered. In the tutorial T4A, the object is loaded in the long directions by pressure at the command each end. Its dimensions are 1000 mm long, 400 mm high. Now all things we will see. Start ANSYS Workbench Design Modeler. Open the file for the quadrant of the sheet. Concept surfaces from sketches. Details of the surfaces we will see in our ANSYS. Generate, extrude. Click the project tab. Advanced and simulation, new simulations. Select the geometry, select surfaces, bodies, and mesh environment. Click on the edge selection filter, select the left edge, apply X component. All this we will see. Magnitude also, we will give magnitude also, and solution. We will create this all this step by steps. And pressure vessel. Problems that are axis symmetrical in nature can be solved with two-dimensional models using ANSYS built-in analysis methods that automatically incorporate the hoop direction stress in the analysis of the 2D model. The process is very similar to that employed in this process is the same as previous we have seen. And last one is the line model, body model. This process is also same previous. We will see in ANSYS, open ANSYS Workbench, main page, and after that static structural here, static structural drag and drop, double click on engineering data. We are selected as already structural steel. Go in projects and right click on geometry, new design modular geometry. Now here we need to draw one geometry. Here XY plane, normal view, go in sketching and select the one rectangle from here. Now it's okay, and select one circle and draw here one circle. Give the dimensions, general, this one and this one. After that, diameter here. You can see diameter is 10. meter, and this one is 32 or 33. Enter. And V2 is 25. Enter. It is completed. Generate. Now go in concept and click on the surface from sketches. Now here you can select sketch 1, apply, and generate. You can see this one is created. After that, open model. Go back to the ANSYS main page. Double click on model. Now you can see model is open. After that, surface body, you need to increase the thickness. Click on here and give the 10 meter. Enter. Mesh generate. Right click and generate mesh. It is generated. After that, go to the static structural and add fix support. Here, right click, insert, and fix support. Now select one edge, apply. Now just right click and insert. After that, force here, force also, and select this edge, not this. You can see this edge, one edge is selected, and magnitude is 50. Enter. Now solution you can insert from here also. In solutions, add total deformation. After that, uh, in stress, apply equivalent stress, and again normal stress. Here normal. Now right click and solve. Just click on here, total deformation, equivalent stress, normal stress, you can see and you can view. Click on here, you will get total deformation, equivalent, and normal. This is a solution. Result is completed. This session is completed. Thank you.